Hello, welcome to Algebra 1. We've covered a tremendous amount of material so far. We've covered how to simplify fractions, how to work with fractions, some basic ideas of variables and equations. Now we need to dive into a little bit of theory before we can make a little more progress. So through your book you will see definitions like this one we'll talk about in a second. I'm going to go over them. You won't use them to solve most of your problems, but they are necessary for you to understand what's going on. So you understand, the core fundamental theories behind algebra, right? And none of them are hard. I can make them all very simple. I do need to caution you that some of these things we're going to talk about are going to seem really obvious. But in math, you have to start somewhere. So we start with the things that are obvious and we progress from there. So the first thing we need to talk about is this idea of a real number. A real number. Basically, I've written it right here. Any number on the number line. Number line, I'll draw a picture in a second for you here, but basically it's the numbers that go positive off to the right and then also go negative off to the left. Any number on the number line, positive, negative, and 0. Right? So basically it's any number you can possibly think of, except imaginary numbers. And we haven't talked at all about imaginary numbers, but you need to kind of be aware that the reason they're called real numbers is because these are the real numbers, the tangible numbers that you can touch. But you also have this thing called imaginary numbers that we're going to talk about a lot farther along in algebra. And those are very useful also. Just because they're imaginary, don't let that fool you. They're extremely useful in algebra, but they're not the types of numbers that you'll put on the number line like I'm talking about that go off to positive infinity and then off to negative infinity. So in any case, real numbers are basically any number you could possibly dream up that's not imaginary. It doesn't have an I in there. And then the imaginary numbers have the letter I associated with them. We'll talk about those much farther in the future. Anyway, examples of real numbers would be numbers that you're dealing with all the time. The number 1, the number 2, things like that. But also negative numbers like negative 4, negative 3.7, negative 2.9999, the number pi, the famous number pi that I know you've heard about from geometry, 3.14, and there's a bunch of decimals after it. That is a real number. So any number that you can possibly think of, positive number, negative number, we're going to talk a lot more about negative numbers here in a little bit, so don't stress out if you don't know what a negative number is. And also the number 0, that's a real number also. Any number you can dream up is called real. Okay, the only time it's not a real number is when there's an imaginary I in there, involved in there. And I know you don't know what that is yet, but just keep in mind that we're going to talk about those in the future. So now that we've got this definition of what a real number is, essentially any number you can dream up, positive or negative, including decimals, fractions, things like that, we're going to talk about something in algebra called the closure property. Closure property. And this goes in the category of things that you're going to look at once I explain it to you, and you're going to say, well, that's obvious, right? And it is obvious, but it's something that you'll need to know in algebra, what the name of it is. So if you have two numbers, call one of them A, and the other one we'll call B. Two numbers A and B are real numbers, which means any number that's not imaginary, any decimal, fraction, positive, negative, 0, any number you can dream up that's not imaginary, then the following thing is true, and we call it the closure property. The number A plus the number B, this is going to blow your mind, is unique and real. Okay, what this means is that if you have two numbers, A and B, like A could be 2 and B could be 3, if you add them together, the result is a unique number. Only one number is the sum of these two, and it's also a real number. So that means when you add real numbers together, you get real numbers back. So 3.5 plus 6.97, those are two real numbers. You're going to get a real number back, and only one answer works when you add these guys together. And this works for all real numbers, negative numbers, fractions, decimals, things like pi that have infinite repeating decimals. If you add them together, you're going to get a unique number that's also real. That's called the closure property. And along those lines, you have something similar. If you take that number A and you multiply it by that number B, these are multiplied together, guess what? It is also unique and real. So this is why I'm saying sometimes you look at these things and you're thinking, well, these are obvious. What I'm basically saying here is that if I take the number 1, that's a real number, and I multiply it times the number 7, that's the real number, the answer, there's only one answer, and it's also a real number. In other words, you're not going to get an imaginary number back. And I know we haven't talked about imaginary numbers, but I have to kind of start somewhere. That's called the closure property. And I'll just write some quick examples here, kind of obvious things here. But if you take 3 plus 4, you're going to get 7. There's only one answer there, and it's a real number because the things you started with are real numbers. 2 times 6, there's only one answer, and it's the number 12. And this number 12 is the unique answer. The only one that works as an answer for 2 times 6, and it's a real number as well. All right, so now we're going to switch gears a little bit, and we're going to talk about another property. So that's the closure property. You may be asked on a test what the closure property is, and now you know. We're going to talk about the commutative property. Commutative property. And the reason I had to start this section with telling you what a real number is because all of these properties are basically going to assume that if A and B are real, in other words, A and B are not imaginary numbers, then the following thing is true. And the commutative property is very simple. It says that if you take the number A, which is a real number, and you add it to B, which is also a real number, you'll get exactly the same thing as if you start with the number B and you add the number A to it. Okay? Extremely simple stuff, right? What this is basically saying here, if you want to take an example, is if I take the number 5 and I add it to the number 9, what am I going to get? I'm going to get 14, which will be exactly the same thing as if I start with the number 9 and I add the number 5 to it. I'll also get the number 14. So in other words, whether or not I take the 5 plus 9, the A plus B, or if I flip it around and change it around and do 9 plus 5, I get the same answer either way. All right? So that is called the commutative property. The order of the addition does not matter. The order of that I do the addition of those numbers doesn't matter. And that's something you know from when you were 2 years old and you started counting, rocks. It doesn't matter if you start with 2 plus 3 rocks or 3 plus 2 rocks. You always get the same answer. All right, so here's the commutative property for multiplication. A times B is going to give you some answer which will be exactly the same as B times A. And so, an example here would be, for instance, 2 times 8. What does that give you? Well, that's 16, right? It's going to give you the exact same answer as 8 times 2. Commutative, it falls under the commutative property because for both of these operations, addition and division, the order of addition and multiplication doesn't matter. Okay, so if we had to summarize this lesson up, and we're done basically with this lesson, we're going to introduce these two properties. One is the closure property. All it says is if you add two numbers together that are real numbers, you're going to get a unique answer that's also real. You won't get any imaginary numbers as an answer. Same thing for multiplication. The answer is unique and real. And the commutative property in English just basically says the order of addition and multiplication as operations, they don't matter. Whether or not you take 3 plus 2 and 2 plus 3, or 16 times 4 and 4 times 16. The answers that you get are always going to be basically the same. And these are number examples, and this is the kind of thing you'll see in your book. So I'm trying to break it down and make it easy for you to understand. We have to kind of plow through some of these properties. You won't be solving problems using a lot of these things, but it helps your knowledge of what you're doing. And as we go farther in the class, we will be using these properties like commutative and things like that to understand more complicated topics. So it is important for you to understand. Follow me on to the next lesson, and we will learn about some additional properties in algebra.